Hello everyone, my name is Cyrus and welcome to the first in a three-part series of videos that will cover IP routing. This video is going to focus on static routing, and I'll be walking you guys through both the benefits and drawbacks as well as the best use case scenarios for implementing static routing into your network. Afterwards, we're going to run through some syntax for adding static routes and then get into an example I have ready for you using Packet Tracer. Getting right into it, static routing is generally a simple way to route traffic in relatively simple networks, which makes it easy to deploy. Because static routing does not require any extra data obtained from routing protocols, it has much less overhead than dynamic routing. Since static routing requires that you manually direct all the network traffic, you ultimately have a better knowledge of the entire network and where all that traffic should be heading. While static routing does allow you to have more granular knowledge and control over a given network, the larger and more complex the network is, the harder it becomes to use static routing reliably, since you have to manually enter routing information such as IP addresses or interfaces on all of your hardware. This not only means that static routing becomes notably more error-prone, but it will also not update alongside any network changes that are made. And it's because of these drawbacks that static routing is mainly used in smaller environments or in specific situations where network traffic is very predictable. When setting up static routes, it is important to keep a couple of its key features in mind, those being administrative distance, directly connected routes, recursive routes, and floating static routes. Administrative distance is simply a metric used by routers to determine the best path to the destination of the packet. By default, static routes have an administrative distance of 1, meaning that the static route will always be used over any dynamic route if left unchanged. Directly connected routes are routes that are set up using the output interface of the router instead of the next hop address that you would normally use in a recursive route. Lastly, floating static routes are static routes that act as a sort of backup to a pre-existing route and will have a higher administrative distance set in order to be used that way. Alright, now really quickly before getting into the example, here are a couple commands we'll be using to set up these static routes. The first being show IP route. Now this will give you a current list of all your available routes, those directly connected and created by any dynamic routing protocol or static route that you have set up manually. And in order to set up those static routes, you'll be using the IP route command. There are two variations of this command. The IP route command is IPv4, and there is another command, IPv6 route, which will allow you to create routes using IPv6 addresses instead. So now that we've gone over the basics, let's jump into the example I have set up on Packet Tracer. Alright, so now that I've gone ahead and loaded up the Packet Tracer file, let's go ahead and take a look at the network I've set up, and from there we'll go ahead and start creating those IP routes. So getting started, over on the left we have the 10.20 network, on the bottom we have the 10.30 network, and on the right we have the 10.40 network. Now, connecting all three of these routers, there are two separate networks. One is the 10.23 network and the 10.34 network. Now, with the current network setup, the plan is to have R1 and R3 send all of its network traffic over to R2, who will then have different IP routes to send all those packets over to either the 10.20, 10.40, or its own respective 10.30 network. So in order to do that, we will go ahead and set up what is known as a gateway of last resort on both R1 and R3. And so in order to do that, let's go ahead and hop into R1 in global config mode. And we'll go ahead and type IP route. And in order to create a gateway of last resort, all you have to do is type in all zeros for the IP address and all zeros for the subnet mask as well. And then tell it what IP address or interface you would like to send that traffic to. And so in our case, we will be sending it to the 10.23.0.2 IP address, and go ahead and enter. Now just to check our work, we'll go ahead and do show IP route. Do show IP route, since we're in global config mode. And you can see right here, gateway of last resort is set to 10.23.0.2, which is perfect, meaning that all of its traffic that is leaving the 10.20 network will be sent to that IP address for R2, for the serial interface on R2 on the 10.23 network. So now with that done, let's go ahead and do the same thing for R3. Let me just move this over. Let's go ahead and type in IP route, all zeros once again. And this time we will be giving it the IP address of 10.34.0.2. Alright, so once again, let's go do show IP route, and gateway of last resort is set to that IP address now. Alright, so now that we've gone ahead and set both R1 and R3 to send all of its data over to R2, let's go ahead and create some static routes for R2 in order to better enable it to handle those packets. Alright, so first let's start with creating a recursive route over to the IP address of R1's serial port. So in order to do that, we'll hop right back into R2 and we will type in IP route. If you want to head to the 10.20 network, 10.20 network, go ahead and send all of your traffic over to the 10.23.0.1 IP address. So taking a look at that, do show IP route. You'll see we have created a static rule, or a static route to this IP address if we get anything destined for the 10.20 network. And so now that we've handled the 10.20 network, let's go ahead and show the 10.40 network some love and create a static route for that as well. So I'm just going to go ahead and tweak our previous route over here. So now instead of the 10.20 network, we're saying if you want to reach the 10.40 network, go ahead and send all those packets over to the 10.34.0.1 address, which is the serial port for R3 on this network. Alright. Sorry, I almost forgot to hit enter on that one. Alright, so now that we have those set up, we'll go ahead and try ping test. So from PCA, let's go ahead and ping PCC on the 10.40 network. So 10.40.0.5. So you can see over here, that's the IP address of PCC. And immediately we get start getting replies from that. So we're all good on the 10.40 network. Let's go ahead and try to ping PCB over here on the bottom. Go ahead and type in 10.30.0.5. We get a request timeout at the beginning, but then we do start to actually talk to PCB over on the bottom. Guys, that has been setting up static routes for a network. Remember guys, setting up static routes is fairly simple. However, getting to a bigger network, it can become a bit more complicated and a bit more error prone. So I hope you guys learned a lot from this video, and thank you for watching.